I have another geometry problem here, and this is problem 71. And it says, suppose a running track is constructed of a rectangular portion that measures 2x feet wide by 2x plus 5 feet long. Each end of the rectangular portion consists of a semicircle whose diameter is 2x. Write a polynomial that determines the perimeter of the track in terms of the variable x, and the area of the track in terms of x. Whoa, what's going on, right? Well, we have to look, perimeter we use as the measure of the outside of a shape. And so we have a shape here whose outside is in yellow here, this bit, and this bit of a rectangle, plus these two bits of a semicircle. So we're making the perimeter all in yellow. But we don't use the width like we have if it's just a straight rectangle. So let's try to put this into equation terms, right? I have one length and another length, so I have 2 times the length, plus I have half a circle and half a circle. Well, 2 halves of a circle is a whole circle, and the outside of a circle is the circumference. So we'll just call this C for right now. So the math symbols I'm writing down right now are not to solve. They're really me thinking. And I'm saying, well, I've got 2 lengths from this little rectangular thing that's hiding right here. And I've got an entire circle. Even though it's broken apart, I've got an entire circle. And so I have its circumference. Now, the circumference of a circle is 2 pi r. And it says this in the front of the book in our geometry formulas. And a thing to note about the radius is the radius is half the diameter. And we use this a lot. Well, if the radius is half the diameter, it also means the circumference is pi times the diameter. This is something that you want to pay attention to, and you want to get used to these different things we name in a circle. So the diameter is all the way across the circle, and the radius is from the center to the edge. And what I tell a lot of my physics classes is diameters are easy to measure. If I have something circular, I can wedge it between like a vise or a caliper or something, and I can measure its entire diameter. But actually physically measuring a radius, I have to find the center, and that's hard to do. But if we build something circular, it's much easier to put a stake in the center and take a rope out and trace it. And so that's why we talk about circles in both diameter and radius. One is easy to measure, one's easier to construct. And in life, you have to sometimes measure things you already have or construct new things. So we talk about them both very interchangeably. Mathematically, the radius is a much better idea, but when it comes to getting data from the real world, you're going to have to deal with what you measure. And in this case, it's the diameter that's measured. So we can say, we can substitute, using our parentheses, the length of one of those sides plus pi times 2x. All right, this is looking good. Well, we have an idea here. This we can simplify. And so if I multiply or distribute this 2 through, so I'll do my distributing, I'm going to get 4x plus 10 plus, and I'll write this in an order, you'll see this a lot, 2 pi x. You'll find that numbers like pi, it is a number, get written second after a coefficient, so if you have a multiple number of pi's. So we always kind of talk about the counting numbers and decimals that we can have first, then in these strange little symbols, these Greek that represent a number, and then our variables last. Now, I'm going to rewrite this in descending order as 4x plus 2 pi x plus 10. And you'll find a lot of textbooks, because I can add these coefficients of x, will do that. They'll go 4 plus 2 pi times x plus 10. Now, when you go to enter things into a calculator or actually use these, the 2 pi plus 4 you can approximate to a decimal. And I noticed your textbook does this first answer here. But if you ever look online or talk to other people, you'll see that this happens also. You will notice if we distribute, it's the same answer. And so either or, it's a valid way to go. All right, now we want to look at the area, the insides here. I'm going to switch over. I'm going to use red for area. I think I'm going to scroll up a bit. But we want to notice the areas is going to be the inside here, the bit I highlighted in orange, and the inside in blue here. So we have two shapes. We have an entire circle still, and we have the entire rectangle. And so my area is going to consist of the area of the two things. So let's see here. Let me find. So the area of a circle is pi r squared. Again, there we go. Oh, my pen is freezing up on me here a second. Give me a second here. Might need new batteries at this point. Pi r squared. If you look in the front of the book, this is what it gives you. But remember that we have a measure in diameter. So this is pi r over 2. Sorry, let me say this right, d over 2. The diameter divided in half. Which is okay, because we're gonna be plugging x into here, and this will simplify for us. But that's the area of the circular bit. The area of the rectangular bit is my length times my width. And my length was 2x plus 5. And my width was 2x. And the width is, of course, what made the diameter here. So I will also simplify that here. So I'm just keeping track of things, right? But it just wanted us to build an algebraic expression. So I have this first one plus the second one. But notice here I have a 2 over a 2. That's a 1. So I can simplify this even one more time to pi x squared. I like that. I don't have to deal with any numbers being squared. Doesn't always happen, but we'll take it here. And so that's getting added up front, pi x squared, plus 2x plus 5 times 2x. And so I will need to distribute this 2x through the parentheses here. So I'll leave the pi x squared up front, pi x squared plus, draw my arrows for distribution. This is going to go to the first part and then the second part. So my first is 4x squared, and my second is plus 10x. And so my area ends up being pi x squared plus 4 x squared plus 10x. Again, I can combine these. I think the book writes it in this way as 4 plus pi times x squared plus 10x. But either of these is an acceptable answer.